Welcome to BC Gnomonics. In this video, we're going to take a look at the Regiomontanus altitude dial and explore its ability to find time at night using a selected star. Now, to accomplish this function, the dial needs two key features. Namely, it needs to include a list of stars and their declinations along its declination scale. As you can see here, this dial has several. And secondly, it needs a method of converting the altitudes of those stars to true solar time, in this case by means of an included stellar volval. Now, before we get started with the procedure of this function, it's worth going over a specific feature of this dial, which is its somewhat unusual method of declination setting. So usually the declinations included are bounded by the winter and summer solstices. That is negative 23.4 degrees and positive 23.4 degrees. But in this case, there are no zodiac scales at all. Instead, the raw declination values are used, ranging all the way from negative 70 degrees along the top outermost scale here to positive 60. Now, this makes finding the time using the sun and setting the date a little bit more cumbersome than it otherwise would be, but it increases the width of the scale to accommodate stars whose declinations sit outside the range of the tropics. Now, I will just take a moment to describe exactly what declination is, if that wasn't already clear for the sake of this demonstration, because it is obviously quite relevant to this dial and its operation. So using this diagram here, we can see that the summer solstice embodies the sun's northernmost path for a given latitude, and the winter solstice embodies its southernmost path. If we use the equinox as the sort of baseline here, call that 0 degrees of declination, the extremes here, the summer and winter solstices, are synonymous with our date, our zodiac degree, call it whatever you would like. At the end of the day, those values are numerical angles away from the equator. So, for example, at the summer solstice, the sun is at its northernmost angle away from the equator. It is at 23.5 degrees, 23.45 technically. And at the winter solstice, the sun is at its southernmost angle away from the equator at negative 23.45 degrees. So when I say positive or negative declination, this is what I'm referring to, whether the sun or a star is above or below the equator. So in most cases, you'll simply think of this as date. Think of June being up here, December being down here, the rest of the months being between this range. This range between the summer and winter solstices defines every possible position in the sky the sun can occupy for a given latitude. That is known as the celestial heliodrome. And if you imagine it from a terrestrial point of view, as you can see here with this person standing here, any star that falls outside of those tropics will not be able to be seen on a traditional dial. As I said before, typical Regiomontanus dials only include the regions between the tropics in their declination settings, as those are that's the region that includes dates at all. But including numerical declination broadens that range. So for example, if you had a star just a little bit past the Tropic of Cancer here, that wouldn't be included on a typical Regiomontanus dial, but this dial is able to include those values. So just to make it as clear as I can, we have 23 right about here, negative and positive over here. So if this were a typical dial, typical Regiomontanus dial, it would only include the declinations within these two lines, like right about there, excluding every potential star beyond this point. Southern declination. Over here, nothing north of this point in the northern region. So hopefully that was able to clear a few things up. I thought I would include this extra explanation just in case my mention of declination wasn't intuitive. But anyway, back to the demonstration. Now, just as a bit of an aside here, if I were to set the date in preparation for finding time with the sun, I would find the date along the outer scale here, set it, and note where the rule points along this outermost declination scale. For example, today's date, August 27th, there it is, 2, 4, 6, 7 right there. I can see that the declination is positive 10 degrees. And that is positive as we are approaching the fall equinox very soon. Now I would take that to the front of the dial and use that to inform my declination setting along here, knowing positive 10 degrees. But that's for the sun. So if I were to set the dial for use with Arcturus, let's say, Arcturus is right here. That 12 will be important later. I undergo a similar procedure, but instead of setting the solar declination, I will use the declination, the unchanging declination, as informed by this star pointer here. So, as usual, I will set the latitude first. So that is, for me, 44 degrees north. The latitude scale on this dial is just inside the declination scale, by the way. And the intersection point that line makes with my star is where I set this pointer. So as you can see here, Arcturus defines a line down just south of 20. That is, let's just say that's positive 19 degrees running through that point there. I have the first part of my setting. Now for the second part, I need to set that same declination, this time for the bead and on the plumb bob. So referring to my secondary declination scale, I will cross the string against the 19 degree marker. And again, this is positive 19 degrees, so I will use the upper part of the scale. And at this point, I will set the bead to the noon position while the string is crossing 19. So now the dial is ready to be used. Now, as I said, we're using Arcturus as our model here. Let's just pretend that it's nighttime, and I can observe Arcturus. I know that it's in the western portion of the sky. So, knowing that it's in the western portion, once I've taken my reading, I will use the afternoon scale of hours as opposed to the morning scale. Just like with the sun, if it's in the western portion of the sky, I know to use the afternoon scale. Now, just with the sun, likewise, I will take my altitude reading. So pointing my dial up into the sky, inclining it, making sure that Arcturus sits right in line with my sights. In this case, it is okay, perfectly safe to view Arcturus directly through the sights. Not with the sun, though. I would use the shadow instead. But once I have that alignment all set, I take the dial down and see the results of my reading. In this case, we have 5 p.m. on the afternoon scale. Now, this is not the true solar time. For that, we have to refer to the reverse side of the dial. So this is where the stellar volvel comes in. So Arcturus before, as I said, was numbered 12. Each star, on this dial at least, has a number associated with it to make this reverse scale a little bit more compact. So I find that star, I find Arcturus here. In this case, it's right there, number 12. So using the volvel, I set the time measured to point to that star. So 5, I point going right to Arcturus. There. Now the next step is to find the current date along this outer scale. So as I said before, today is August 27th. August 2, 4, 6, 7, right there. And the final step is to observe the intersection point of that date and the scale on the volval. So as we extend a line from the current date, I see that it crosses this volval scale at right about 9 p.m. As 9 a.m., the sun would have already risen at my latitude, and we wouldn't have been able to use the star. So clearly it is 9 p.m. And that is the current solar time at this moment. So just to give a quick recap, select your star, first of all. Know which star you're looking at in the sky. Know whether it's in the eastern or western portion. Select the intersection of the latitude and the declination line defined by that star. In this case, we used Arcturus. Set that same declination again on the secondary scale. In this case, that was 19 degrees. Take a reading, find the time. In this case, again, just repeating what we did, we got 5 p.m. Take that over to the volval. Rotate the volval so that the reading from your altitude points to the star of choice. In this case, 5 points to Arcturus. Find the current date and watch for the point of intersection that date line makes with the volval scale. In this case, 9. Thus, it is currently 9 p.m. true solar time. Now, I hope this demonstration was helpful. And one more thing, if you are here for this, well, there you go. Thank you for watching.